So otherwise I'll say your name if you say that word, and then you'll get in trouble. All right, that was so-and-so saying their pet. Okay, so anyway, these are graphs of sine and cosine functions. Sine and cosine, and that's kind of what we did with that little investigation. So hopefully you have some how do you say that word?
Familiarity.
Yeah, that's the word I was
That's your
looking for.
LA teacher.
Familiarity, at one point, yeah. Familiarity with this. So if you graph a sine function, you should have discovered when you were doing this that it looks kind of has this nice up and down nature. They call it sinusoidal in nature if it goes up and down. That's not a perfect sine curve, but it's okay. And it goes up to a maximum of 1, and it goes down to 1, negative 1. And then, anyone know how long does it take to repeat one cycle? 2 pi. Very good. Okay, so that corresponds to how long it takes to go around the unit circle, right? So like here is, this point would be what? If this is 2 pi, what would this point be right here? Pi 0. So this corresponds to the point on the unit circle. Pi sine is 0, right? And that's where this graph comes from. If I actually went through and plotted all my points, like this point right here is the point pi over 2, comma 1, right? If I put pi over 2 on my unit circle in, I get out 1, and this is the point 3 pi over 2, comma negative. All right? And so you played with this a little bit and you moved things around, but as long as I'm here, I'm going to graph cosine. Does anyone, on that lab I didn't really talk about cosine, did I? Okay, so I'm going to get a better graph with arrows on both ends. And I'm going to not make it dotted, and I'm not going to be pink anymore because I'm a macho guy. Okay, and I'm going to go like this. And the graph of cosine is very, very similar to the graph of sine. So looking at the unit circle, where does cosine start? What's the cosine of 0? 1, right? And what's the cosine of 2 pi? What's it, if you go all the way around the circle, where do you end up with? At 1 again, right? And at pi, if I were to go here and put the point pi, what is the cosine of pi? Look on your unit circle. Look on the unit circle. Here's my unit circle. We'll draw a little unit circle. Right here. Where's my circle tool? Circle. There we are. Do I have a circle? There's a unit circle. Okay. So when my angle from here to here is pi, what is the y coordinate on my unit circle? Negative 1. And that's where this value comes from. So this is negative 1, and this is positive 1. And so the cosine function, and here at pi over 2, cosine is 0, so this would be pi over 2 right here. And this would be 3 pi over 2 over here, where cosine is also 0. So if you were to graph the cosine function, it looks something like, whoops, I missed that point. Okay, but it goes something like that. This would be pi over there. And then it's sinusoidal, meaning it keeps going on forever and ever. And so it kind of keeps going like that, on and on forever. And if you notice, cosine and sine, very bad graph, but it's hard to draw my movie board. Who can tell me what the difference is between cosine and sine? How could I change a sine graph into a cosine graph? I could either move it to the left, or I could move it forward to the right, like that would be 3 pi over 2, or move it back pi over 2. But we'll talk more about shifting things tomorrow. Okay, so this is a graph of y equals cosine of x, and that's kind of, it all comes from the unit circle. It's not magic or anything like that. Just goes from plotting the points as you go around the unit circle. Now, okay, so if I want to shift these graphs or stretch them or do funky things to them, I look at the number before the sine or cosine. So we'll just look, it works the same way for sine, whether you're in sine or cosine. So say I have y at, don't do this, I don't like pink, okay? Y equals 3 sine of x. Y equals 3 sine of x. Look at that's a sine right there. Who could tell me what that looks like compared to y equals sine of x? What you did in the lab. What does it do? It just goes up 3 times as high, right? It still has the same. No, it doesn't go 3 times faster. It just stretches by a factor of 3. So it would go up to 3 and down to negative 3, and it would still take 2 pi to complete one complete cycle, they call it. So that would be the point 2 pi 0. And so this number right here it's not really called the amplitude, the absolute value of that number. So in general, if you have y equals a sine or cosine of x, this number right here, the absolute value of that number is equal to the amplitude. Okay? And the amplitude is just the distance from the center line up to the top. Okay? So it's an absolute value because it's a distance from here up to the top. Okay? So this here, the distance there is the amplitude. If it's a negative sign, who can tell me what would be different? What did you find on that lab that you did? Did you guys figure that out? Come on. It just flips it. So if it were like negative sine of 3x, all that would do would take it and it would make it go the other direction. Okay? But the amplitude would still be 3. Okay? So that's all the amplitude does. It shrinks it vertically, or it stretches it vertically. Also, you have the period. Okay? The period of a sine or a cosine function, period of sine or cosine. How long does it take to complete one revolution and repeat itself? 2 pi radians. Okay? Now, unfortunately, that doesn't go into the equation. What goes into the equation is this number b. Okay? And b, sometimes they call that the frequency. I call that the frequency. And in previous books I've used, they call that the frequency. But in this book, they just call it b. And so b is equal to 2 pi divided by the period. And conversely, the period is equal to 2 pi divided by the frequency. And this is important for you to know for when you're finding what an equation looks like. So for instance, say I had the function cosine of 2x. Y equals cosine of 2x. Who can tell me what that 2 does to your function? What did you discover when you were doing the lab? What does that 2 do? It doesn't stretch, it shrinks it horizontally. Okay? It squishes it like an accordion. Okay? That's kind of what this 2 does. And so in that case, b is what goes into the equation. So this is b. So in general, you have y equals a sine or cosine of b times x. And this all is in parentheses like that. It's the cosine of b times x. And b is like the shrink factor. So if that is a number bigger than 1, it shrinks it by that factor. So in the case of cosine 2x, it's going to go twice as fast as cosine of x. And its period, if I take 2 pi and divide it by 2, which is the frequency, what do I get out? What's 2 pi divided by 2? Pi, which means that it's going to do one cycle in pi radians, right? It's going twice as fast, so it's going to go through that twice as quickly. right? So if I were to graph, if they say graph y equals sine of 2, let's do cosine of 2x, it's going to do that. It's going to repeat itself, and if this is 2 pi, then it's going to do 1 up and down and back in pi radians. So if this is 1 and this is -1, it's going to go down, up, and back up, and it's going to do that in pi radians, because that's a cosine function. And then it's going to do another one within the same amount of time, okay? And it's going to go backwards over here in the same amount of time. So this point over here would be -pi, and so on, right? What if I wanted to stretch it? What would I do? What would y equals sine of 1/2 x look like? It stretches it by a factor of 2, right? So then 2 pi divided by b, which is 1/2, is the same. So the period is 2 pi divided by b, right? 2 pi divided by 1/2 gives you 4 pi. So that one's going to be a stretched out one, because it takes, the period is how long it takes to complete one cycle, right? The frequency, if you want to put a number on the frequency, that tells you, so if the frequency is 2, that means it completes 2 cycles in 2 pi radians, okay? If the frequency is 1/2, that means it completes 1/2 of a cycle in 2 pi radians. And the period is 4 pi, meaning it takes 4 pi to complete one cycle. You understand that, more or less? Okay, so that's how that works. That's how the frequency and the period work. What if I had something like, so then they like to confuse you, so they'll throw you something like the cosine, oh, that looks like a heart, 3 pi, the cosine of 3 pi x, okay? And they say sketch, let's do this, -2, y equals -2 cosine of 3 pi x, sketch the graph. And you go, that's pretty hard, I don't know how to do that. Don't you say that. Or you say, I want to go to sleep. Don't say that either. Okay? Johnny comes, that's where you go. Anyway, so what you want to do, so we haven't shifted things around anywhere or anything. So cosine normally starts up here. Where would a -2 cosine start?
At the bottom.
It would start at the bottom at what point? 0, -2, and then it would complete one cycle. Oh, and so it's going to kind of, they always kind of look the same. And it goes like this, and then it's going to continue on from there, okay? But you have to figure out how long it takes to do that, okay? And if your axes aren't to scale, you need to label your axes. So if the period, if the frequency is 3 pi, that means that the period is 2 pi divided by 3 pi, which is what?
2/3.
Which is 2/3. What that means is that this function completes one round, one cycle, in 2/3 of a radian, okay? So you don't have to put the units on it, but from here to here, this would be the point 2/3, 0, okay? And this would be the point half of 2/3, which would be 1/6, 0, okay? And so on and so forth. So that's how you'd sketch the graph of something that looks like that. Not that hard, is it? Okay. The last thing that I'm going to show you is how do you move this up and down, okay? How do you move some, oh, there's one more thing after this last thing. So say I wanted to do something like y equals 2 plus, let's just do one thing at a time, or a couple things at a time, 3 cosine of x. what is this 2 going to do to my function? What does it do with a parabola? If I go y equals x squared plus 2, what does that do to my function? It doesn't move it right or left. It moves it
Up or down.
up or down. Okay? So in this case, it's going to take my cosine function, and instead of starting at 3, like a cosine normally would, please stop rolling the coins. Henry Harris, thanks. Okay, so instead of starting at 3, where's it going to start? Where's it going to start if it shifted up 2 from 3? 5, it's going to start at 5. So this would be the point 0, 5. And then it's going to do this. It's going to take 2 pi, but how far it's going to drop and all that kind of stuff, this is how I would do it. I would draw the middle line, okay, going through y equals, I don't want to do that. I'll make it dotted, okay? So I'm going to make a dotted line, dotted line. Dotted line, I'm going to make a different color. And I'm going to call this is the line y equals 2. And sometimes they call this the midline or something like that. And then it's going to go 3 units above that line and 3 units below that line. So if this thing takes 2 pi radians to complete one cycle, so the end point is 0, 5, how far is it going to drop? If it goes above 3 units above, how far is it going to go below? Where is it going to go right here? -1, because it's going to add. So this would be the point pi, comma, -1. And we'll worry more tomorrow about exact points that you're going to go to, but this function is going to look something like this, going down to -1, and then back up there to 0, 5. Okay? And so that's how you would graph something that is shifted up or down. Graph the middle line and then figure out the amplitude, and that amplitude will tell you how far to go above and below that line. Not too bad, right? Okay. Then last thing you're going to see is they're going to give you a graph of something. And I made one up on my own, but then I found out that it was exactly the same as the one in the book. Well, I made up the problem, and then I looked in the book. I go, hey, that's the example. I should write math books. Okay? So say you have, I'm not going to draw in the midline. Say you have something that get rid of that. Let's just draw a regular line. And they'll say, from the graph, tell what the equation is. And so here's a graph. And then they have some function that seems to be going up and down like this. See if I could do this how I want to. Like that, and then like that, and like that. Okay? And they tell you that this is the point 0, -1. 0, -1. And that this is the point. Let's find the this point would be the point pi over 2, comma, -5. And they say find the equation of this function. Could you do that? Find the equation. It's a little tricky. Find the equation. So I don't think they have this in the book, but the way I would do it, the middle line, I think, is the average of the y coordinates. So the middle line is y equals max plus min divided by 2. So in this case, that would be -1 plus -5 divided by 2, which gives you out what? -3. So what that tells you is the line y equals -3 cuts this in half. All right? So I'm going to take the line y equals -3, and I like to sketch it in just so that I can see what's going on here. Okay? And I'm going to go, there's the middle line. So that's y equals That's y equals negative 3. The amplitude, so this is the middle line. You should probably know that formula. It's a good one to know. The amplitude, I'm going to write it up here so I can keep on the same page. Amplitude, in this case, well, you can kind of look at the picture. If this is negative, if this is, whoops, negative 3, not 3. If this is negative 3, how far up is it to negative 1? How far is it from negative 3 up to negative 1? 2. So that's my amplitude. The other way you can do it is by going the max minus the min divided by 2. So if I did that, okay, I would get negative 1 minus negative 3, right, divided by 2, negative 5, I'm sorry, minus negative 3, which is, sorry, minus negative 5, which is negative 1 plus 5, which is 4 divided by 2, which is 2. Or you could just count up how many spaces is it from negative 3 up to 1. So the amplitude in this case is 2, and I know my shift is negative 3, and then all I have to do is figure out the period, or the frequency. What's the period in this case? How long does it take to complete one complete cycle? If it's pi over 2 to here, how far is it to here? That's pi, right? So the period is pi, and that's not what goes in my equation. What goes in my equation is b. So b is equal to 2 pi divided by the period, which in this case is pi. So that's also equal to 2. You see that? So putting it all together, the equation looks like, we know the amplitude, we know the shift, and we know the frequency. So it's like y equals, and you put the negative 3 in front so it's not confused with being part of the cosine function. The amplitude is 2, and this can be modeled as a cosine function of x of, how many x? 2x. So that would be the graph of a function that looks like,
Why is there negative 3 in front?
just because if I put it over here, you could put it over there, but then you might think it's cosine of 2x minus 3.
That's why
which
you
is
use
not.
parentheses.
Okay. Yeah, you could do it like this and then put the negative 3 in, but this is the way they do it in the
Doesn't
book.
that shift it?
And it's just, nope. The shift we'll talk about tomorrow. This shifts it, yeah. This shifts it down 3. That's what I did, is I took a normal cosine function
But it starts out negative 1.
and I pushed it down 3. Okay? Yes, but cosine of 2 cosine x would normally start at 2, right? So I pushed that function down 3 units. Okay? So now it's from positive 2, would push that point down to negative 1. Okay? I know of what I speak. Alright? So, that's how you do it. Do you think you could do that for homework?
No.
So we pick up, so tomorrow you learn about shifting them horizontally and some word problems based on this. Okay? So that's all it is, and your homework is on my website, and I'll post what that is. I'm going to pause my video here. My 23